So let's talk about this. Click and closed. I'll show you a couple shortcuts. Do a quick review and get you going. Click all the way closed for me real quick. All the way closed. All the way closed.
Yeah, Jaden. Close it.
All the way, there we go. Okay, that's looking better. Closed, there we go. Okay, so when we want to factor the expression, what we're really, these are problems, by the way, from Unit 2. Right? This is nothing new. You've done this exact problem probably at some point. Maybe slightly different numbers, but you've done this problem back in Unit 2. If we're writing it in factored form, what is factored form? A times, factored, x
Minus P
times x minus q, good. P and q are x-intercepts. A is just a dilation factor, right? So that's all we got to do is get it into that form. But all this means is factor it, right? That's it. If we're trying to convert a quadratic expression into factored form, we're just factoring. So what do we always do when we factor first? You're going good. Common factor. Greatest common factor, right? So what's the biggest thing we could undistribute here? 2. Positive 2. Okay, so this is equal to. We could take out a 2, leaving us with what? If I divide each of those terms by 2, what's the first term give us?
X squared.
Second term.
5x.
Third term.
-6.
Okay, good. So right away we can see that A equals 2, right? Okay. Now what? Well, we got to take all this stuff right here and break it up if we can into factors. So then we end up with f of x equals 2 times, what do we get? What are my magic numbers here? What do we have to multiply to? You got to multiply to -6 and add to. Okay, now this is a tricky one. This is one that people miss quite a bit. This combination of numbers, because it's easy to get fooled, right? There's multiple combinations of factors of 6 that could work together to give you a 5. You've got to be very careful about the signs. If they're multiplying to a negative number, what's it tell you about the signs? One's negative and one's positive. If they're adding to a positive, which one's bigger? Positive must be bigger if they add to a positive. So now that helps.
Is it 6 and -1?
It's positive 6 and -1, isn't it? Not 2 and 3, right? Okay, make sense?
I would have got that wrong.
It's, well, if you don't take your time, you might. But if you take your time and you think about this, you know, if I'm going to have a positive number and a negative number that multiply to -6 and add to 5, 2 and 3 don't work, right? If I took positive 3 and -2, yeah, those multiply to -6, but they add to 1, not 5. So we could cross those ones off, right? Okay, so that's our answer right there. Okay, just factor it. Okay, what about one like this? Now, I'm going to show you a shortcut. Okay, I've dragged you through the completing the square stuff enough, probably. Those of you who are going to go a little further with math, I think everybody in that camp has probably labored through completing the square enough to understand how it works. But there is a shortcut. Okay? Some of you found it. What is it? Now, if we're trying to put this into vertex form, right? All we're doing, when we're trying to write a function in a specific form, we're just trying to fill in the values of the parameters, right? In this case, a and h and k. If I knew what the values were of a and h and k, I could plug those numbers in and I would be done, right?
Is it the one you mentioned a little bit with class, the
Yeah.
H equals -2?
There you go, good. So you guys, I think we were a little ahead. I think I maybe mentioned this. So right away, we can see what's the value of a? -3, isn't it? Because this is in the form ax squared plus bx plus c, right? So a is, just by inspecting that, the coefficient of x squared is a, and a is -3, right? Okay, now our trick. If we want to find h and k, you just got to remember that h is what again? In terms of a, b, and c? negative b over 2a. So what is that? So what's negative b? 12. 2 times a is negative 6. So 12 divided by negative 6 is good, negative 2. So we know h is negative 2. How do we find k if we have h? How do we find, k is just the y value. How do I find a y value if I have an x value?
F of
What do we do?
K.
What?
I had a pit stop.
Uh-huh. So how do I, once again, how do I find a y value if I know an x value for any function? What do you do?
Function of, two.
Yeah, I just plug it in, right? Plug the x value into the function to find the y value, right? So k is just f of h, so it's f of negative 2. Well, if I plug negative 2 in for x, I'm going to get negative 3 times x squared, but x is negative 2. When you're evaluating a function, make sure you always put the number that you're inputting in parentheses, right? So you don't make the mistake of not squaring out the negative, right? If you don't do that, sometimes people will make the mistake and say, that's negative 4. You put the whole thing in parentheses. Minus 12 times x, but x is negative 2, minus 18. And what's that work out to be? What's negative 2 squared? 4 times negative 3. Negative 12 times negative 2. So negative 12 plus 24 is 12, minus 18 is, okay, so there we got it. So now k equals negative 6. And so if I just plug all that stuff in to my function, don't I just get f of x equals negative 3 times x minus negative 2 squared minus 6.
Oh, wait, so much for stuff, huh?
That's a little easier, isn't it? Right? Okay. You good? All right. So far, so good. Okay. What about this guy? If we want to, so if we want to write this function, this goes back, this is Unit 3. This is a question literally taken from Unit 3. But it's been a little while, so let's just take a brief review of this, right? We want to write this function in vertex form. So once again, all we're going to do is figure out what are the values of a and h and k. Well, h and k are simple. What are h and k? No, h and k. A is the dilation factor. H and k are what coordinates of what?
X and Y.
For what point though? The vertex. There you go. Right? So then we know that here's our vertex has coordinates, what, 3, negative 5? So that's just hk. You got those two. The only thing we got to do now is we got to figure out what a is, right? What did we do to dilate this thing, right? So we've got to compare the shape of our parabola to the parent graph parabola. Well, what's our parent graph for this kind of a function? Y equals what? What's the simplest?
X squared.
X squared, there we go, right? So we got the parent graph, y equals x squared. Okay, so what's our parent graph do? We go over 1 and up 1, right? Over 2 and up 4. Over 3 and up 9. Over 4 and up 16. I can't even go that high, I guess I can. Right there. Over 5, which is what we did here, right? Over 5, and we're going clear off the chart up 25 to find our next point. Okay, but we went over 5 and down 5. Right? So our dilation factor then must be whatever we multiplied the original y value by on our parent graph that goes way the heck up there. Right? Whatever we multiplied that by to get our new y value. Right? So in other words, a times 25 must equal -5, right? Because that's what we do. We multiply the dilation factor by the parent graph y values to get the dilated y values, right? So what's that? What would I do to solve for A? Yeah, divide both sides by 25. Good. So I'm going to get -5 over 25. Well, what is that? -1/5. Good. The shortcut would even be, we always know that A equals, remember, it's going to equal the dilated, oops. Dilated y value divided by parent. Which takes us right to there, doesn't it?
So that would just be -1/5 x minus b.
There you go. Right, so we know A is, look at our ingredients here, we know A is -1/5, H is 3, K is -5, so all that stuff is just gonna give us f of x equals -1/5 times x minus 3 squared minus 5, right? If I just take all that stuff, that's what it gives me.
We put that in the box.
That's it. Put that in the answer box and we're good. Okay, so what does it do then? So what if, how would the problem change if I did this? Oh, well,
No.
here, let's pick.
You're bad. I'm so full. But you missed the first one.
You missed twice.
Twice? Then you're really bad.
Okay, here we go. Have a look.
I always thought you made it.
Have a look here. So what about this one? What if I want to choose the graph of this quadratic function, right? It's in standard form, but all I need to know to find the graph, if I know A and H and K, I got it, right? Everybody agree? So all we got to do is find A and H and K. Well, what's A? 4, right? Because it's already in ax squared plus bx plus c form. So we can see right away that A equals 4. How do we calculate H?
Negative b times 2
Negative b over 2a.
divided by
So then what's negative b?
It's okay.
Negative 48. What's 2a?
8.
8. So what's negative 48 divided by 8? Right? And then all I got to do to find k is plug that into the function, right? So I'm going to get 4 times -6 squared plus 48 times -6 plus 140, right? Everybody agree? And so what's that going to give me? -6 squared is 36. 4 times 36 is going to be 144. But that's going to be positive 36, right? -6 squared is 36. So I get 144 minus 48 times 6 is going to be, shoot, what's that going to be? That's going to be, that's an old 96, so that's going to be 288. So minus 288 plus
Okay, what would be plus
140. No. 48 times -6 is negative 288.
Oh, I thought it was.
So then 144 plus 140, isn't that just 284? Minus 288 is -4. So we can do this easily then, right? We know that the vertex is going to be at the point -6, -4. So it's going to be right there, right? and a is equal to 4. So we're gonna stretch out a normal parabola by a factor of 4. So we're gonna multiply the y values by 4. So what's the easiest one to use?
1.
Yeah, instead of going over 1 and up 1, we're going over 1 and up 4. There we go. So over 1 and up 4 puts us right there. We can reflect that one over the axis of symmetry to get another point right there. And so this is the graph we're looking for. Here, I'm going to try to graph this. I'm going to do a terrible job, I can't tell you.
Technique.
Yeah, right. So let's find that one. Okay, that's close, but not quite. Oh, that looks pretty good, doesn't it?
Yeah.
That's it. What do you know? Right there.
Look at it.
There we go.
You saw me make that.
Bang.
Makes me feel so good. Okay.
That sucks.
That's it.
Okay, what about something like,
That sucks too. All the hills, anywhere are sucks.
okay. Okay, what about this one? Let's talk about one of these, real quick. So, what form is this in? Factored form, very good.
Factor point.
Okay, so this is in the form,
What's all the different?
f of x equals a times the quantity x minus p times the quantity x minus q. What's the value of p?
2.
2. What's q?
Name 14.
No,
Just regular
14. Okay, so one thing we know is that our, oops. Yeah, so we're gonna get,
Third one.
we're gonna get something like that, right? So we're gonna get x-intercepts are gonna be at 2 and 14, right? Okay, but we need to know where the vertex is also. Right, so what's the value of h? Now, if I know that the x-intercepts are at 2 and 14, what's that tell you about where h has to be, the x-coordinate of the vertex? It's got to be in the middle, right? Because symmetry, doesn't it? So it's got to be halfway in between. So to find h, then, we're just going to average those, right? We know that h is always equal to p plus q divided by 2, the average of the two, right? So we're going to get 2 plus 14 over 2. What's 2 plus 14? 16 over 2 is what? 8. Ah, okay, so then we know that over at 8, there's the axis of symmetry, right? And if I know that h is 8, k is just going to be f of 8. All I got to do is plug that into my function. So I get negative 1/2 times 8 minus 2 times 8 minus 14, right? William, that's enough of that problem, William.
Hey, can you do this one?
You have to do that final, please?
What's that?
You have to do that final step, or do you just find the H and?
No, because I guarantee I'll put some tricky ones on there, but that won't be enough. I'm pretty tricky, if you haven't noticed.
So then you just do F of.
So what's 8 minus 2?
6.
What's 8 minus 14? 6. Okay, you'll notice, every time you do this, those two numbers are just going to be opposites. You'll see that pattern. So negative 1/2 times 6 is negative 3, right? Times negative 6, what's negative 3 times negative 6? So k equals 18, so we go up here to 18, so that's our spot right there, isn't it? Right.
Don't you multiply the negative 1/2 by the negative 16?
That's what he did. That's how I got the move.
Right, get positive 18. right?
Oh, never mind.
That makes sense? So then that's our winner right there, isn't it?
Really rude.
Okay, make sense?
Trey,
Trey, come on, Trey, what are you doing?
I didn't call him Trey.
Tracy.
Hey, what do winners carry?
What a what?
Trey. Wasn't that good?
Okay, I'm gonna take a picture for our notes here. What do you say?
Put on the instruction
Smile.
notes. It says-
Are we
I
in
see you taking my phone, I'm not taking your
Oh,
phone.
darn it.
You start eating drugs.
I'm not like definitely though. Just like-
Okay, real quick, focus up here. We got one more example and then I'll let you out of here. We got 5 minutes, we can do this. So, if we're gonna solve this one, this would be an example where we would not wanna use substitution. Agreed? There is no easy variable to isolate up here. No matter what I do, I'm gonna get fractions if I try to solve for a variable, which I don't wanna deal with, right? So this is an example of where we'd use elimination. What's the easiest variable to eliminate there? Y is correct. So there's a bunch of questions at the start of this assignment where they'll say things like multiply the first or the second equation by what? In this case, we would multiply first equation by 2, exactly, right, to get rid of the y's. Second equation, we'll leave alone. So then if I distribute a 2 all the way through, I'm going to get 8x plus 4y equals negative 10.
How do you choose which Y to use?
How do I choose which variable to use, to get rid of?
Yeah, and then how come you chose 2 instead of -4?
Well, okay, because now think about if I were going to get rid of the x's. I need everybody's attention up here, please.
It's just easier for you to know what you're.
Scatter. Thank you. So if I want to get rid of the x's, think what I'd have to do. I'd have to multiply both equations this time to get an opposite number of x's in both equations. I could multiply the top one by 3 to get 12x, and the bottom equation by 4 to get negative 12x. But I don't want to multiply two equations if I don't have to, right? So instead with the y's, if I just distributed 2 all the way through, look what happens. I get 4y and negative 4y, and so I eliminate the y's. That's the whole point, is to eliminate a variable. So these guys cancel, and when I add these up, what do I get? 8x plus negative 3x is 5x. Negative 10 plus negative 9 is negative 19. Right? So I got to divide both sides by 5, and I get x equals negative 19 fifths. Now that's kind of ugly, right? That I've got a negative 19 fifths there for x. Okay, but it's just a fraction, right? So when I plug that in, let's go ahead and plug it into the bottom equation, how about? So I get negative 3 times x, which is negative 19 fifths, minus 4y equals negative 9, right, when I plug that in. When I multiply fractions, I just multiply straight across. So negative 3 times negative 19 is positive 57. 1 times 5 gives me 5 on the bottom, right? Minus 4y equals negative 9, right? So now what? If I'm going to solve for y, I really don't want to have to deal with all these fractions. So my thinking is on this, you don't have to. You could just subtract 57 fifths from both sides and then divide by negative 4. But I don't really feel like subtracting 57 fifths from negative 9, so I'm going to clear the fractions. I'm going to multiply both sides through by 5, right? So if I do that, those cancel, I can make it. I get 57 minus 20y equals negative 45. Now that's easy. I'm just going to subtract 57. So that's going to give me negative 102. And I'm going to divide each side by negative 20. And I end up with
Just one quick announcement.
Y
on the
equals
budget.
negative over negative is positive, 102 over 20, so I can reduce that to 51 over 10.
That's gonna be one of the first
So there's Y,
today, and
So there you have it.
there's X.
right,
That'll be-
Ringo.
So if you want to compare negative 19 fifths, 51 tenths. Boom. Got it.
Those
Okay.
are the ugliest numbers.
Those are pretty bad.
I was never told to judge.